Hello there. I want to share a story of a design problem that I faced today and came up with a solution for. In particular, a sort of a dynamic data fetching scheme. Maybe I should just call it a new fetching scheme for objects in the time traveling debugger that I'm working on. I want to share this because I think there's a few things about it that the way the problem first occurred to me, and then the way that as I approached the problem, the way that my conception of the problem kind of changed over time, and that aspect of it, I think, can be instructive for developers, which is why I want to share this. First of all, I was writing down by the way, whenever I encounter a difficult problem, and this one was definitely should be categorized that way, as a difficult problem. Whenever I do have to do that, I usually go into a brainstorming mode. And there are various ways that I brainstorm. Sometimes I brainstorm by just pacing in a room back and forth, holding my head down, and just be sort of consumed by deep thought. Other times I am doing that while I'm driving the car. Probably not the safest thing to be doing, but other times while I'm doing other stuff. But one of the better ways that I do brainstorming is with a pen and notebook, and in this case with several different colored pens. So I have these colored pens that I use, which I love. Okay, and I want to share my notes with you. So first I came up. I was thinking very hard about two different approaches. The current approach versus which I have listed here as 1 and 2. So approach 1 was I would fetch the objects lazily as the user interface required them. First, to give you some context, the user interface that we're talking about. This is the user interface that I am working on and have been working on for a while. I call it the Deep Zoom Debugger. So you can zoom in to a sort of execution of a piece of code. And if you zoom into a particular function call, you can see the details of what happened during the execution of that function. And then because functions can call other functions, you can zoom in more and more and more and so forth. While you're looking at this code, you also get information about like the state of some variables in the code. So I have built several versions of this, or this code has evolved over time. The current problem that I'm facing is recently I have managed to log the state of the program into a database as a series of snapshots. Okay, so every single snapshot of the state of the program is stored in this snapshot table. And each snapshot contains a stack and a heap, but those fields are actually pointers to something in the object table. And in the object table is where all the data of the program actually live. So, and also an object store like this is in a semi-JSON format. For people who has been following my status updates, you're familiar with this, but for those who are not, this guy here there's a notation here that I use. This star here, star 17, means this value actually points to object 17 in this table based on this ID. So if I want to, we first read in this object, which contains a board, a player 0, 1, and 2. But in order to figure out what is actually in board, we actually have to then fetch object 17. And an object 17 is actually a heap reference. That's how I decided to denote heap references. It's an object with just an ID. And that's actually pointing to 1. But that's number 1 in the heap. And there's another way. I probably don't have time to describe how the heap works right now, so I'm going to skip over that. But point being that I have a large database of objects. Within each object, there could potentially be a reference to other objects. So, so you're looking at something like, okay, so for each snapshot, let me draw this like this. So for each snapshot object, you've got a stack, which is a pointer to some object, which is in that object table. You also got a heap, which also is a pointer to some object. The stack contains stuff inside it, which point to other objects. And in turn can contain pointers to yet other objects. And the same can be said of the heap. The heap is actually a huge bag of objects, so potentially huge bag of objects. And in the scenario of my little tic-tac-toe game, it evidently did become a very, very large bag of objects. Okay, so but the objects could in turn have pointers to other objects and so forth, and it could go kind of, it could go several hops until you get the entire graph of objects that are required, that are sort of transitively referenced by this snapshot. If you walk all of these references, you could potentially get a large number of objects. So given all of that, my approach one, which is what I initially went for, is load these objects recursively and on demand in a lazy fashion. Which means I'm going to sort of first just load in the snapshot, and then we're gonna load in this stack object and this heap object. And then if I've got front-end code that wants to look at what this pointer is pointing to, then it would request a fetch of this object. And if I've got code that actually wants to see what this is pointing to, and then at that point it will lazily fetch this object and so forth. So all objects are fetched lazily. I think I might, if it's not too much trouble, I'm gonna switch to the branch of code that still uses that approach. I think that one is called database, and show you what that looks like in code. So this is the state of the code at the beginning of this problem solving session, or not the beginning, but it is the first draft of this problem solving, in which I took approach number 1. And you can kind of see that these orange parts that are displaying the values of variables, they actually came in a little bit later, quite a bit later than the source code did. I'll show you that again. So you can see these orange bits, yeah, they're sort of like coming in late, late to the party. like a movie star. And the reason for that is because of the lazy loading scheme. I have code here. This is the code that loads in that information. I have code that is like taking the stack. This stack is actually just a reference to the stack. In order to actually get the actual stack, it has to ask the object cache for the stack. And the first thing you get the object of this ID from the object cache, it will return null back. So it will say, oh, if the cache doesn't have it yet, I'm gonna not display anything, which in this function you do that by returning an empty array. But if it is there, then we'll have to sort of look up yet another reference. It's kind of this is actually the case where like, oh, I need to fetch this guy, and if it's not fetched yet, then this get will actually trigger the object cache to fetch it from the server, and then when the server returns that, then it triggers another render, which would in turn re-trigger this method getting called, and when that re-trigger, the next time this will return an actual stack and allow it to go through. But the next time it actually is going to ask for this guy, and then when it asks for this guy, the first time it won't have a result for that one yet. The object cache is going to go fetch it, and then this time it'll return empty. But then the next time, when the render is again re-triggered, it can go further into the next step. So as you can imagine, if we have several of these steps, which did end up happening in a different method, where we have like, this is like step 1, step 2, step 3, each step causes a lazy fetch. If you have a lot of those steps, it actually could take a while for all of the information to get here, because each request is a round trip to the server, and they have to happen serially. And that's actually one of the problems with this approach, which I actually didn't even write it down in my pros and cons list. Oh, where's my pros and cons list? Oh, there it is. Okay, this is my pros and cons list. Doing pros and cons is very important in your problem solving. I feel like, because a lot of times you can feel like you're very attached to one solution versus another, but it's only when you list the pros and cons of each that you're able to think in a more unbiased way, or in a less biased way. Okay, so anyway, the approach number 1 was fetch the objects recursively, and approach number 2, what was the opposite of fetching the objects lazily? Well, it's to prefetch the objects. So this is approach number 2, have an API in the backend that recursively fetches objects on the behalf of a single function call. So what does that look like? Well, that looks like this. Basically that graph, well, I deleted that graph, but I'll just redraw a simpler version of that, or perhaps a slightly different version of that. So I have a snapshot, and again, it's got a stack pointer. Stack, does that look like stack? And a heap pointer, among some other stuff. And each of them are sort of pointing to this objects, and objects can be pointing to other objects, and so forth. And this could get, I don't know, somewhat deep. The other approach is like you make an API call to the backend, and the backend does the work of traversing all of these objects for you, and then returns all of these objects back to the front end. So all of these object traversal of the backend basically ends up generating this subtree for you and returns it all to the front end. And so I was comparing these two approaches, and I don't remember when I implemented number 2. So let's go through the pros and cons. The cons of number 1 versus number 2. The cons of number 1 is the if statement checks in the front end were getting pretty ungainly. So in particular, this one and this one, I was having here, that is getting kind of ungainly. Now you usually write it the most straightforward way the first time through, so I was doing this without trying to sort of simplify the syntax or extract the syntax out. But still, this syntax is getting ungainly. That's the first con of approach number 1. Approach number 2 was that sorry. That was the cons of approach number 1. Let's go to another con of number 1. Another con of number 1 was lots and lots of network calls, which we did end up seeing. I'll show you. So if I go to the network tab, as you can imagine, because when there are lots of objects and you're trying to recursively load all of them, we're getting this network call count. When we're loading in this information, we're getting 98 requests at this level. If we drill into another level, another one that has more complicated stuff in it, say this one, our request count jumped to close to 300 at this point. And if we drill down even more, then it'll jump more. So it's the front end is making a request for every one of these hops that is needed to get the information that the front end wants. So large amount of requests. Okay, so these two were the cons to approach number 1 that I've identified. What about the cons for approach number 2? Approach number 2 is that I thought of was you could, while you have fewer network calls, which is the pro of the approach number 2, but if you resolve all of the objects in a graph for every snapshot, well, some of the objects might be shared by multiple snapshots. So for example, I have, like, if this is snapshot number 1, I have snapshot number 2. Snapshot number 2 might actually be pointing to some of these same objects. That's possible. And it could potentially even be that the redundancy is a lot, as in snapshot number 1 could be sharing a lot of the same objects with snapshot number 2. And if that was the case, and I decided to return all of the objects for every snapshot, then we would end up transmitting the same objects redundantly. And also, if we were sharing them, storing them in memory, we could also end up storing the objects redundantly in memory. So that's I actually didn't realize this after I had implemented approach number 2, the backend. I'll show you a little bit of how approach number 2 worked. So basically, this is the output of approach number 2. Although this is in a state where I had another enhancement that came after, but I'm gonna ignore that for now. So this is approach number 2, where if for a particular function call, it fetches all of the child function calls, all the snapshots, as well as all of the objects that can be referenced from any of these snapshots. So it walks the graph of, say, like if the stack is pointing to object number 2, then it's gonna go fetch object number 2 and put it in this object map. So in this case, the stack points to object number 152, 900, 152,931. So that object is going to get returned later in this object graph. Where is it? There's a lot of objects in here. I even forgot the. Where is it? There it is. So that's that object, right? So I changed it to work like this, and only after I had implemented this did I realize that this con that we could end up with a lot of redundantly transmitted objects, and that actually takes up a lot of bandwidth and also potentially a lot of memory. And the pros are actually the reverse of the cons in this case. So the pro of approach number one is the caching. It just works very simply. There's no need to refetch the same objects, but just based on the ID, and everything is immutable. So there's no worrying about whether an object has to been updated and I have to refetch it. There's none of that. And the pros of approach number two is the front end only has to there's only one check in the front end to see whether the required data is here or not, instead of several of these looking up of the cache and then checking where this data is there. We would only end up with one of these if we use approach number two. And then also a pro of approach number two is we would end up with fewer network calls. Now, one thing to say about situations like this is that I think people very often sort of put themselves inside this false dichotomy of, well, I can only choose one of the two approaches. But in fact, when you're doing this kind of brainstorming, part of the reason you want to do this kind of higher level brainstorming is to find the solutions that you have not thought of before. And usually that comes about by thinking sort of very clearly about the pros and cons of each and how each of them sort of interact or relate to each other, or why each of them have those pros and cons and those characteristics. So when I put all of this stuff on the page, I came up with a third option, which I called the tweener, which is often the case. If you want the best of both worlds, can you come up with a in-between solution? And the in-between solution that I came up with is, how about have an API that recursively fetches objects, so just like number two, except that you also pass in a list of objects that the front end already has in the cache, so that the back end knows these do not need to be resended back into the front end. So that is saying, if you have a picture like this, actually, let me draw another picture because we need more space. Okay, so we have a scenario where we have a complex graph of objects, which is stored in a database in the backend, right? So I'm gonna call this backend, and you want the front end to be able to access that information, but not all of it because there's too much information. This database is very, very large, and the whole point of storing it in the database, like look how many objects we have. That's a lot. So the whole point of storing it into the database is so that we don't have memory issues. So we want the front end to have only a partial amount of data that the database has. We want the front end to be like a partial mirror of all of the data. It's like you only have a small percent of all of the data that the backend has, and you can think of it like Google Earth, right? Google Earth is the concept that I based this thing on. And Google Earth has an incredible amount of data embedded in it. But at any given moment, you're only looking at a very small subset of all of that data. So we got all these objects in the back end, like a potentially very, very large object graph like this. Okay, that's enough. The front end wants to be able to say, okay, well, there are some snapshots. I'll call these SSs. So a snapshot is like an entry point. We have a whole bunch of SSs. Let's call this SS1, SS2, 3, 4, and so forth. And each snapshot sort of points to some object, maybe something like this. And that object becomes like the entry point of this snapshot. Actually, each snapshot has multiple pointers, but let's simplify a little bit. So we want to say basically that when the front end is looking at something that needs this snapshot, say, actually this slightly more complicated than that even. There's function calls, and that each function call has a collection of snapshots. So each function call has a collection of objects, and at any given moment, the front end is like looking at one particular function call. Well, not exactly, but we simplify it, pretend it is. So the front end is looking at one particular function call. Say this smart computer calculated move function call, and it's like, hey, backend, please load me in all the data I need to see for this function call. So send an API call asking for information related to this function call. And then we have the API basically go through every snapshot that's related to this function call, and then walk the graph, walk the stack, start at the stack, and then heap, traverse through all the objects that would have been encountered by looking at every snapshot that belongs to that particular function call. And you end up with a subgraph of the entire graph that is stored in the database. You send that back into the front end. And the front end is gonna get this graph, this subgraph of the objects in this format. And the front end is responsible for caching these, putting it into a cache. So there's a cache, which is a map. So maybe like 1, points to A, 2 points to B, 3 points to C, etc. Where each A has like a corresponding object in the database. So this is like a partial mirror of the database. And my idea was like each time I send an API call, I also send the list of the IDs that are already in my cache here, so that the backend will know to skip these that the front end already has. Right? So that was my tweener idea. However, the problem with the tweener idea is that the list could get long. The list of all of those IDs could get very long. And that could be a problem. And then I thought more about whether there's a way to solve that problem. And there was. It's called sessions. Sessions is a concept in HTTP servers that has a long history, so we can bank on something that has quite a bit of history, which is just HTTP sessions. So I implemented HTTP sessions in the server. So the server code, using this express session module, and you just use it like this, and we're able to store information related to the session. So I use the session to store all of the IDs that have already been fetched for this particular client, and that's remembered. And during this deep traversal, which is implemented by this get objects deep function, if it sees that it's already in that list of IDs, then it will not do the fetching. So that's how that works. So I'll show you that. So initially, we made this request to get this very large list of objects. If we make the request one more time, in the second request, we actually get an empty map because all of those objects are in the session now, and the backend assumes that your front end already has that in the cache, so we don't have to return them again. Now, if we fetch for a different function call ID, then we get something a little bit different. We still get some objects, but it's actually not the full set of objects because there's some overlap between the result of this call versus the result of a different function call. So we don't get the full set. We just get the objects that were missed by the first call. Yeah, so that's what I ended up coming up with. Let me show you the code for that. My branch is called data fetching scheme. Oh, yeah, okay. I'm not gonna bother committing this actually. Okay. Let me see if this works out. It did compile. Okay. Look at the network panel for how many requests that this UI makes now. So we made one request at this level for the main function, and once we get here, we made a second request for rendering this play game function. And if we drill into the smart computer, we made 5 requests. So I think one for this is winner function, and then another one for this smart computer. So the number of requests that are needed has dramatically gone down. We're literally making one request per drill down to a function call that we're looking at. And that's basically as good as it can get in terms of saving network calls. Another thing I'm thinking about is the size of the cache in the front end. We probably want to control that in some way because I don't want that number to keep going up. I want a scheme for purging objects that are basically no longer being viewed when they can be purged. So that's something I am planning to work on. It's one of the things on my list right now, but I think that's doable with the scheme that I have. Okay, I'm gonna leave you with some closing remarks. Okay, what are my closing remarks? One thing I want to mention that I wrote down here, I wrote down though that I should make a video, which is what I'm doing right now. The other factor I also just talked about, I probably want a good scheme for purging objects. One more thing I want to mention is confidence, the role of confidence, the role that confidence plays in the solving of complex problems. I feel that it's actually really important to build up your confidence by building the simplistic solution first before you feel confident enough attempting the more sophisticated solutions. And that was the case for me. I work with a lot of more junior developers than me that can from time to time can feel like they don't have the confidence to take on the challenges that are in front of them. And I just want you and want them to know that, well, that kind of problem exists for a very senior developer as well. Someone like me who has solved like a lot of different problems before, and even with all that experience, it still was difficult for me jumping right in and attempting the most sophisticated solution. Because when you're dealing with something that's brand new for you, you actually don't have a good footing, enough of a footing to know what the potential problems are until you actually get into it. Which is why it's so important to start with building out the simplistic solution, which for me, that was approach number one. Approach number one seemed to me to be the more straightforward one to implement, and I just did that. But when problems surface, then that's when I sort of regrouped and did some brainstorming and see if I could come up with a better solution than that. And another thing I want to say that is that it's actually very important and very beneficial to try multiple solutions before settling on the one that you want at the end. And sometimes it may not even be the end. Sometimes that's just the solution for now, and later on you would still have to change it if you encounter other problems. Don't look at it as throwaway work. Although one way to look at it is like don't be afraid of doing throwaway work. I've built a lot of things that I then later thrown away, but what you gain through that experience is the learning that you get from it, and being able to compare two different approaches and analyze the pros and cons of each allows you to understand the entire problem better, and also allows you to become more skilled, level up in your problem solving skills and coding skills as well. So that's what I gotta say here. Thank you for watching, and I hope that was helpful to you.